This is a construction video for the Launchpad Nike Hercules. This is the motor mount, and the main body tube has its been glued together, ready to go to the next step, which is building the 4-to-1 transition piece. It's cut from heavy cardstock and then glued together with centering rings. There will be more about this later. This is a measuring tube that I built from a paper towel roll. It helps you set the mid bulkhead and weight, and also the engine mount depth. You can mark it on either end and then slide it into the body tube to set it up. This is how you should mount the 4 body tubes. You can glue it to the 1/8" strip of balsa wood and then put a loose wrap of elastic around it to hold the body tube against the 1/8" balsa strip. This is after all 4 body tubes has been added to the main body tube, after the 4 booster tubes. Again, wrap it each time with elastic and let the glue set as you go along with it. After that, you have to insert the parachute bulkhead. It holds the parachute at a certain distance. It keeps the center of gravity from shifting. This is the 4-to-1 transition piece with the top centering ring. And I'll turn it over here, and you have the 4-to-1 transition centering ring that goes on top of the body tubes. You slide this down on the body tube against the 4 booster tubes. There's 4 moon pieces that go into the ends of the booster tubes, and on 2 of them I added a weld nut with a piece of 1/8" plywood in order to provide a mount for positive motor retention. This is how I glued the weld nut and the in the plywood to the moon piece. After you've inserted everything, you put the transitions on the 4 body tubes and hold it upside down so that the glue all sets and everything is good and tight. Then you add the top transition piece that goes to the sustainer section of the Nike Hercules. This is a view of the weld nuts and the moon pieces after they've been glued into the base of the body tubes. The next step is adding the booster wrap, which is cut from heavy cardstock and then gingerly slipped onto the booster tubes at the base and then slid down to where it's flush with the base, as you can see in this photo. The next step is to add the other transition piece and the main 3¼ inch body tube, and they slide down onto the first transition piece, and there's a centering ring in the middle of the main body tube. You can see in this photo the 1.6" BT60 body tube in the middle. The next step is to add the other 2 transition pieces at the top, which provide the profile of the sustainer section of the Nike Hercules. Unfortunately, the first try that I made, the transitions didn't fit very well, and I tried several different ways to make them fit, including splitting the transition and seeing if I could glue it down. That unfortunately did not work. Fortunately, I had scanned all of the items beforehand. This is how you make the forward wings on the I used white glue on this after clamping the wings together and then using a file to cut the notch for the radar antenna to go into. That's the little 1/8" dowels that you see there. This is a set of two number 11 blades that I used to cut the 16th inch balsa wood strip for the bottom brace on the built-up booster fins. And it worked very well. It was easier than sanding the 16th inch balsa. First I tried to improve the fit by expanding foam inside the transition pieces. That unfortunately did not work, so I ended up cutting, hot wire cutting foam pieces and then filling it with spackle and filler compound, Elmer's wood glue filling compound. That worked very well. Fortunately, I had scanned all of the transition pieces prior to trying to build the model, so I had spare transition pieces that I could build. This is the new transition pieces in place on top of the cut foam transitions to provide additional stability for the wings and the fins. It's very important to get the fins perpendicular so you can cut a cardboard template in order to help you get them straight. Since this model was going to be much heavier than normal, I decided I wanted to have launch lugs on it, so I built from 1/8 inch balsa built up and then inserted a brass thread nut into it, and I put it at the top of the booster wrap and right at the 4-to-1 transition piece. Once you have the transitions in place, then you can continue to glue the rest of the fins on, which is really the hardest part, getting everything lined up. I found that it was better to put the sustainer wings on first and then the radar fins, and then to glue on the base. You can see here it's standing up without the fins on the boosters. This is how to align and space the directional fins on the sustainer. You use a 3/16 inch bit at the top and a 1/4 inch bit at the bottom, and use a scrap piece of balsa and clothespins to align it. In order to improve the stability of the wings on the sustainer, I added a paper tape along the root edge of the wings, since those are very long and was very flimsy with just the glue on it. After the paper tape went on, I went in and did epoxy fillets with 30-minute epoxy, doing 2 at a time, so that the epoxy would not run down the wings. A jig that's built to hold the wing or the sustainer horizontally helps. This is the booster fins with 2 holes drilled in it. I decided that the original design was not stiff enough for flight, so I drilled 2 holes to receive some expanding foam, 2-part expanding foam. I built a form in order to keep the wings or the fins flat when the foam was expanding, and marked it bottom and top so that I could put them on the fins. As you can see on this thing, then I used standard binder clips in order to hold the cardstock built-up fins in place. At that point, I just poured the 2-part epoxy into the fins, let it expand, and waited for quite a while in order for the two-part foam to really cure before I removed the parts. This is the way that I measured the two-part foam, and I used about 15 milliliters of uh, foam total, 7.5 of both parts A and B, and this is the look after the foam had been poured into the quarter-inch holes in the root edge of the fins. Even with the forms, I still had some uh, bumps on the fins, so I needed to fill them and work on them in order to get the edges and everything perfectly straight. As you can see, things are coming along nicely here. This is the actual filleting process for the wings on the sustainer. This is how to align the booster fins. Use a piece of 1/8 inch plywood glued with together, two pieces of 1/8 inch plywood glued together with 3/32 balsa in between, leaving a slot so that the edges of the fin, the booster fin, can fit into that slot. You can then, using a 3/16 inch piece of wood glued to aluminum angle, get exactly aligned with the sustainer fins. As you can see here, the booster fins fit into the slot well, and that holds them very stably and straight. This is a photo of the fins after they've been filled and sanded to make sure that everything is flat and in good shape. Okay. At that point, glue the fins onto the booster and I used a 3-pound soft scuba weight in order to hold the fin in contact with the booster tube. As you can see, the alignment is held very well with the paper clips and the aluminum angle there. And here you can see the soft weight to hold down the booster fin and get good contact while the epoxy sets on the booster fin. This is the finished rocket showing, or the finished fin set showing that the alignment of the fins is very, very close to perfect on this. That was one of the things that I was concerned about in the construction of this particular rocket kit. Here is the sustainer and booster with fins attached. Everything has been filled and sanded just a bit. Still has some work to do, including the hinges and actuators on the fins. At this point, the rocket weighed 696 grams. With the addition of the styrofoam transitions and the foam in there, I added paper tape to the root edge of the booster fins as I had done on the sustainer wings in order to provide additional structural stability on it. This is a picture of the glued on hinge and the actuator simulation items, and this is after they have been sanded down and cleaned up a bit. It's best to build a jig to do this in order to get the alignment straight. This is the attachment of the booster fin brackets, which is one of the last parts to do. I found that it didn't really pay to add these at this stage of the game because I had to add another layer on top of it. This is kind of a close-up of the jig that I had built to hold this thing horizontal and make it rotate where I could get to all sides of the rocket. This is after some filling and work on it, and the attachment of the hinges and the actuators does stabilize the directional fins quite a bit, and it's a good thing because they're pretty wobbly. This is the rocket getting ready for final finishing. Again, a shot of the lineup of the wings showing the alignment there. This is the launch lug bulkhead that, or not the launch lug, but the rail button bulkhead, both front and back, that was installed. I had put 6x32 screws in there. This is after the first layer of primer. I used Krylon sandable primer on this, and then sanded it, saw any imperfections, refilled it with Bondo glazing putty, and reprimed after sanding it down, and put about 4 coats of primer on it to get everything nice and smooth and looking good. The nose cone I had covered actually with a paper cover in order to fill the balsa grain on top of epoxy, and then painted it. In order to install the pitot tubes, which are actually paper clips, I used a pair of popsicle sticks, and a popsicle stick is exactly half of the width of the front radar antenna on here. And this is a picture of the line that I was able to draw on there in order to get my alignment correct for a hole, which I drilled with a number 56 drill bit in order to put the pitot tube paper clips into the front radar wings. Just a progress shot of the nose cone. Everything is filled, primed, wet sanded, looking pretty smooth right now. I did have to add another half-inch washer on the front nose cone in order to get additional weight. This is the wet sanding of the primer, and once you've finished all sanding on it, it's now time to attach the wing guides, the steering wing guides. These are very small and very fragile pieces, so you need to make sure that you're not going to be sanding over them once you've got them installed. So I chose to wait until this point to add the this is a picture of the paper clips, which are supplied in the kit and are provided to simulate the pitot tubes for the front radar wings. The number 56 drill bit was just about perfect. I was able to put epoxy inside of the hole and then add the paper clips and then bend them to where they were straight with the radar fins and the parallel with the axis of the rocket. I added second layer of the booster fin brackets in order to provide definition, because after several layers of primer, the definition was quite muddied. So I added an additional layer on top of this in order to make it look good on the finished rocket. And at this point, everything is smoothed out, laid out. It looks good for the final paint job, and it took a lot of work to get this rocket to this point. This is a photo of all of the items that it took to build this rocket, starting on the left with the two-part foam, and 5, 12, 30-minute epoxy, water thin and medium CA glue, Bondo and wood filler, plus the Rust-Oleum glossy enamel that I used to finish the rocket with. This is after the first coat of enamel on the outside of the rocket. After all of the work on smoothing the primer and filling the imperfections, it came out looking very smooth and good. Went ahead and put 2 additional coats on there with all of the nooks and crannies on this particular kit. It's hard to get them all covered with just 1 coat, but 3 coats just about covers it quite well. As you can see, the finish is like glass, and it works very well. Unfortunately, some of the detail was washed out by having to put as much primer and paint on it. But you can see the booster fin brackets stand out quite nicely. And this is me enjoying the benefits of all of the work. Grand total of about 250 hours went into building this rocket. The launch pad instructions kind of jokingly say this isn't a fast build, and I would have to concur completely on that, that it's definitely not a fast build. Final weight on the rocket after all of the balance or the stability weights and everything is about 1,045 grams. Coming up here, I'll show you the scale with that on there. It's quite a sturdy rocket with all of the additional foam and backing on the transition pieces. The first launch that I made on this rocket, because it is much heavier than the original plans were, was on a G76. Had about 11 G's acceleration on it. This is the finished rocket, or almost finished rocket, with the Revell plastic kit decals on it, which I think are actually based on the Washington, D.C. livery. Final touch-up on it, I kind of wanted the 4 booster tube bases to be red, just out of craziness. But everything looks pretty good on this rocket. Got quite a few compliments on it. And that's how you build a Launchpad K22 Nike Hercules. Good luck with yours. I hope you don't get discouraged with it. Thanks a lot for watching. Bye.